Nice to see you here this morning. Today we're going to talk about how you can extend invocable actions that you may already have in your org, but extend them by making them available as reactive screen components. And we're going to step through the process of how you can do that. Feel free to scan this if you haven't gotten your Starbucks gift card yet. If you fill out the survey, and one of the first 4,000 attendees will give you a card. My name is Eric Smith. I'm a technical architect at RafterOne. We're a Salesforce consulting partner, and I'm joined up here this morning by Adam White. I'm going to have him say a few words, and then we'll get back into the presentation.
Yep. Thanks, Eric. Yep, so Adam White, ScreenFlow product manager. And it wouldn't be a Salesforce presentation without a forward-looking statement. So Salesforce is a publicly traded company. Please make all purchasing decisions based off currently available services and products. And with that, I have to hand it back over to Eric.
Thank you, Adam. So extending your invocable actions with flow screen reactivity. Basically, invocable actions are meant to be standalone nodes in a flow. But what if you want that same functionality that you're being given in that invocable action, but want that on a flow screen while the user is interacting with the flow? And we can do this by turning that invocable action into a reactive screen component. Now, we see here on the left-hand side of the slide, this is a typical flow where you may be interacting with the user. You get some records, you get some information, you present a screen. And on that screen, we're looking for some input from the user. In this particular case, I have an invocable action that performs calculations on a collection of records. I give it a collection of records, I give it the name of the field, and I tell it the action that I want to perform on that. It could be an average, a sum, a max, a min, any number of things, a count of records. But this invocable action is designed to process that collection. So once we get the input from the user and set our attributes, we can call our invocable action. It's available on the flow. And then we have another screen where we present the result. What did that invocable action do? Here's the answer. We show the screen to the user. And then if they want to repeat the process, maybe different records or a different operation, they can go back and do the whole thing again. But what if we wanted that flow that we see right here to look like this? And we could do that by making that invocable action a reactive screen component. Now, here's an example of the one I was talking about where we're performing a calculation on a group of records. I have a data table. The user's interacting with the data table, selecting one or more records. I have a couple pick lists there that say, here's the field I want you to act on, and here's the operation I want you to perform. So every time they change any of these inputs on the screen, we react to it. The display text component gives us our answer. It's an average, it's a sum, it's a count, it's these records, it's those records, it's this field, it's that field. It's always reacting and updating that information while the user is interacting with your flow. So how do we do that? How do we turn that invocable action into a reactive screen component? So if we look at what's going on behind the scenes, on the left-hand side here, we see our flow. It's sitting in the web browser, and that flow has a data table, it has my inputs for the pick list, and it has a display text to show my answer. But my invocable action is sitting out there in the flow engine somewhere, waiting to take the inputs and give the output. How do we make the two talk to each other? And we can do that with a couple of bridge components. On the flow screen, we have a Lightning Web component that takes these attributes and it communicates with an Apex controller over in the flow engine that is interacting with the invocable action. So we take the inputs into this new component that's on the screen. It talks to its friend over on the Apex side that says, here are all the inputs, call the invocable action, send the outputs back to the screen. Once we have the outputs, we display our result. So we have basically two types of code here. We have a Lightning Web component, which is written primarily in JavaScript, that's sitting on the flow, and we have an Apex class, a controller class. And these two bridge components are what are talking to each other that allows this to happen. So looking on the flow builder, we have, you can see here I have the data table, I have the pick list inputs, and I have my display text that's showing the result, but I have this new component, calculate field summary. This is the new Lightning Web component piece that does these bridge components that's sitting there on the flow screen and reacting immediately to any changes that the user is making to any of the other components on the screen. And it's also taking their answers and sending it to the display text. So again, we have the Lightning Web component, and we have an Apex component talking to each other that allows us to do this. And really, it's the reason we can do it, when I was looking at this, I wanted a way, I said, how can we combine the two? And basically, if you look at it, a Lightning Web component can interact with any Apex class that's Aura enabled. But Apex can also call other Apex components through invocable.action. And that's how I was able to get to this process to link these two together. And I'm going to have samples for you. There's going to be a resource slide and a QR code at the end of the presentation. You'll have access to all of the source code and a template so you could use this with your own invocable actions. But you could take an invocable action that's in your org or one you've already created, modify it to run in a flow, but the whole purpose of this exercise is to, how can you do this without having to change what you already have? And I'm just going to go through some of the considerations that you look at to do this. The only thing I ever found in an invocable action that might have to change is I did have to use global scoping on methods and variables. If we didn't have that, it didn't behave well when we were trying to talk back and forth to them. So that's the only thing you may want to keep in mind on an existing invocable action. Looking at the Lightning Web component, again, the code's probably not readable here, but you will have examples that you can follow in the resources. But basically, the various steps that we're trying to do in the Lightning Web component is we need to expose it to the flow screen. We're duplicating our inputs and our outputs that are going to be required by the invocable action. We'll set any default values, if necessary, in that code. And then we track any of these attributes reactively. So there's a way in a Lightning Web component to be reactive to changes on a flow screen. And then we call that Aura-enabled controller that's going to deal with our invocable action. And then if any error messages come back, this Lightning Web component has a way of exposing those to the flow. And then finally, the results get passed back to the flow so we can do more things with them. The Apex controller on the other side, again, just like the Lightning Web component, we're identifying our pass-through attributes. What are the inputs and the outputs being used by the invocable action? And so with the input attributes, the return attributes, we execute the invocable action as it exists. And then the other thing is, Apex and the Lightning Web components don't always store information the exact same way. So there's some methods in here to handle any necessary conversions of data types. And that's all built into this standard template. And then the results get returned back to the Lightning Web component. As in any Apex that you create, you want to have good test classes. You want to exercise all of the capabilities of that invocable action that you're trying to deal with. And also, you want to try and find ways to generate any exceptions as well in that test class. So I mentioned that you have access to the source code, and I have a few different templates out there for you to look at. If you look on the left, some of the source code, I've identified all of the comments in line with the code. If you prefer to look at code standalone and see all the comments in the margins, I have it set up that way as well. And the nice thing about all of the comments in this code is they're identified as to what pieces of code are static. What do you leave alone? This is part of the template. And what pieces of code do you have to modify to fit your particular invocable action? What are your attributes that you're dealing with, basically? So in a nutshell, that's how it's done. We'll provide examples to you to see how you do this. And then I'm going to turn it over to Adam that says, well, what if you don't want to do all this stuff I just told you about? Well, I do try and stay a few releases ahead of Salesforce when I build out things like this, and Adam's going to show you what's coming.
All right, thanks, Eric. Yeah, so we just saw how you can trigger an invocable action from LWC, but coming soon, there's going to be an easier way. But before I show you, I have to talk about where we're going with reactivity. So a year ago today, we released general reactivity. So I like to divide reactivity into two eras, kind of like Taylor Swift. We've got reactivity with what I have. This is reactivity with data that you get when you load the screen. So when we launched, it was general component reactivity. It unlocked use cases like this, where you could create custom components to fetch data real time. Basically, a component can talk to another component. And we also did something really cool. We surfaced something that the formula team built, which was a JavaScript formula engine. This allows you to calculate formulas real time. The first in the platform, really freaking cool. But there was a bit of a challenge, right? A lot of times you're filling out a form and you need to get data based off of something that user's doing. So this release, Winter 25, we're releasing the action button, which allows you to place an auto-launched flow within the screen using a button, which I'll cover in just a moment. But what if you didn't want a button? Well, we're working on something as we speak called reactive screen actions, and I'm going to show you a little sizzle reel in just a moment. But before I do, if you haven't taken action buttons for a spin, they are really cool. So you essentially place a button on the screen, and you tie an active auto-launch flow to it. You pass in variables from the screen, right? So it's an auto-launch flow. You can do whatever you want. You can trigger invocable actions, transform, get records, sort, whatever you need. Callouts, by the way, all on the same screen. But we got overwhelming feedback that a lot of people don't want a button. That's why we are working on something that we're calling reactive screen actions, where you can trigger the exact same framework, those screen actions, but off any change on your screen. This unlocks a whole set of use cases like this right here, where you've got a car manufacturer with car models based off of record data. You can fetch table data as a user types, cases, knowledge articles, real-time results, right? Summarizing selected rows in a data table, for example. Really common scenario. Or what if you wanted to add up opportunities in a data table? Really common. This last one is really cool, and I'm actually very excited about. We're also making input validation reactive, hopefully this upcoming release, so that now you don't have to click next to get a component to validate. So now, yeah. All right. Really important for these bigger screens that we're building, right? Because you've got this giant form. The user gets to the end and discovers the very first component's invalid. It's kind of frustrating. But if you combine that with a reactive screen action, you could do something really cool where you type into an email field, fetch results as they're typing, service a data table showing duplicate records in the same place. That's really neat. All right, so let's see that exact same demo, but using a reactive screen action. So here we are. We've got our data table of opportunities. It's a little different. I took some liberties here. But we've got operations on the left and fields that we want to summarize on the right. And every time that we change any of these three things, we run a flow. That's pretty cool, right? So we got our operations here. We have fields to summarize. And we've even got logic in there that kind of replicates the cool error checking that you did, where like, what if you tried to concatenate number fields or you tried to add up text fields? We'll throw some errors on the bottom. Anything is possible. If you've got an invocable action, you can use that. You can use transform to do summarization. Whatever you need, whatever your use case is, do it right there with low code. But we like code. Flow and code are friends. The two combined really unlocks the potential for a lot of efficiencies. And here's something else that's really cool. You get real-time debug details as these flows are running. So if you're debugging the flow, you can watch that flow change as you're making changes on the screen. Really neat right there, right? You don't have to click next to get debug details. It's all right there. Now you don't have to go into debug logs in Apex. Well, maybe you still do if your invocable action's not up to snuff, but we'll gloss over that one. So this is the flow that I built using the same scenario, right? So I first do a decision to look and see where are the inputs matching up? Are we trying to concatenate number fields? Are we trying to add up text fields? Have little error messages based off of that. And then using the same invocable actions from unofficial SF, we do collection calculate, which is a really popular one. We extract some strings from the collection if we want to concatenate some names together. All this is a single flow running every time there's a change on the screen. That's pretty cool. So you might be wondering, how do I set it up? So fairly straightforward with a button. You just drag it over and you configure it. So kind of similar experience. What we're thinking here is we'll set it up at the properties, screen properties level. So you'll be able to select an action. And that action is an active auto launch flow. Then you get taken into the action configuration, which is almost identical to an action button if you guys have used that yet. The big difference here is the trigger requirements section down there. This will let you define when you want that screen action to fire. So you can, by default, it'll fire anytime that inputs change. So let's say you pass in a lookup to that record ID input there. Anytime that lookup field changes, it's going to fire the flow. But you can also add extra conditions on top of that using our what I call our modularized condition builder that's used in conditional field visibility right now, but we're moving it over here so that you can specify extra conditions to make sure that it doesn't fire when you don't want it. Like, what if you didn't want it to fire when that record ID was blank, for example? So that is reactive screen actions in a nutshell. We have a lot of resources that Eric has put together here. I've got a really important screen flow reactivity trail mix that has a lot of good stuff in it, including a really important article about data security that I highly recommend you all read as it pertains to screen flows. So definitely scan this, and hope you got to enjoy the world premiere of reactive screen actions.
And if you have any questions, we'll be hanging around here for a few minutes after this presentation, and we'll be glad to talk to you individually at that time. So thank you very much.
Yeah.